In lesson 21, we're going to talk about a very important concept called properties of logarithms. Um, and these properties of logarithms are how logarithms become useful in science. Now, they may not be useful to you, but these properties will be useful in helping you answer your, homework problems and your quiz problems so that you can, hopefully get an A in your math class. But these properties of logarithms really are useful. They're pretty simple, and there's four of them. The first one I call the multiplication to addition. And let me show you what's happening here. You have a logarithm, you have more than one logarithm. So here's a logarithm. And what's important about those two or more logarithms is if they have to have the same base. Okay? And if the two logarithms are being added together, okay, then what you can do is you can condense them into a single logarithm. Okay, so it's called the multiplication to addition, and what we're going to say here is, by example, that log base 3 of 7 plus log base 3 of 5 is equal to log base 3 of 7 times 5. See, what you do is this is your two logarithms become a single logarithm, and then what's inside, it's being added in between, but inside you take the two numbers and you multiply them. Okay, so if you have two logarithms and they're being added together, you can make it one logarithm. Just take one of these, the log base 3, okay? Then just take the little pieces that are inside, the 7 and the 5, multiply them together and put them on the inside, and they create one logarithm. See, what's happening is addition is becoming multiplication, but you can also go the other direction. Multiplication becomes addition, okay? And then we have a very similar concept called, I call it the division to subtraction. You can also call it the subtraction to division, okay? So you can go from division to subtraction, or you can go from subtraction to division. And it's the same thing. If you have two logarithms and you're subtracting one of the logarithms from the other logarithm, you're subtracting, and they have the same base, then they can be condensed together into a single logarithm of the same base, and the one that's being subtracted, that number is going to go in the denominator, and then the one that you're subtracting from, that number is going to go in the numerator. So log base 8 of 10 minus log base 8 of 7 is the same thing as the single logarithm log base 8 of 10 divided by 7. So subtraction becomes division. But you can also go the other way, and you can break apart division and turn it into subtraction, okay? Then we have what I call the exponent to multiplication, or multiplication to exponent property, okay? And the way that works is this, is if you have a logarithm that's being multiplied by a number, okay? So we have 4 times log base 5 of 3. This 4 can actually go inside the logarithm as an exponent on the argument, okay? So 4 times log base 5 of 3 becomes log base 5 of 3 to the 4th power. You can also take a logarithm that has an exponent and move the exponent outside to become a multiplier in front. And so log base 5 of 3 to the 4th power can become 4 times log base 5 of 3. And of course, 3 to the 4th power is 81. So this is the same thing as log base 5 of 81. And we're going to do a bunch of examples, or at least a few examples, of each of these properties. Okay. The last property is called the change of base. And this one is where you actually want to calculate logarithms. The change of base formula goes like this. If you have a logarithm with a base, so this is log base 2 of 19, okay? Well, what we can do is we can actually turn this into a quotient of two logarithms that have the same base. So this will be, we're going to use the natural log, because the natural log is really easy to use. It's got its own button on the calculator, okay? So what's happening is this. Log base 2 of 19 will turn into the natural log of 19 divided by the natural log of 2. So we do a natural log on top of a natural log. So in the numerator, natural log. In the denominator, natural log. Then we take this number that's on the inside and we put it as the natural log in the numerator. And we take this number that's on the bottom and we put it in the natural log on the bottom. Okay? And so now natural log of 19 can be plugged into a calculator very easily. Most calculators have a button that looks like this. It's the natural log button, ln. When you press it, you typically get an ln with an open parenthesis. And so we can just press this button, this ln button, and then key in 19 and close the parenthesis and then press enter or equals, right? And it gives us about 2.9444. If we do the same thing with 2, natural log of 2, and we get 0.6931. And if we divide these two numbers, we get 4.2479. And so we can use this change of base to calculate logarithms in a calculator. So if I want to know what log base 2 of 19 is, I just key in natural log of 19 divided by natural log of 2, and I press the equals button, and I get 4.2479. And so that's what I want to do right now is in the rest of this particular video, I want to look at some examples of the change of base and use a calculator to calculate them. So grab a calculator for the next part. Okay, so let's do this one here. Log base 4 of 35, change of base. Formula is going to say that we're going to do the natural log of 35 divided by the natural log of 4. And I'm not going to do the intermediate step. I'm just going to grab a calculator. In fact, I think I'm going to see if I can go to the NumWorks calculator here. Okay, here's our NumWorks calculator. I'm going to go ahead and open up the calculator here. And down here you can see there's the button ln. We're going to key in ln of 35 and close the parenthesis. Then we're going to hit divided by. And in the denominator, we're going to put natural log of 4. And so you can see here we have the change of base. Natural log of 35 divided by natural log of 4. If we hit execute, you can see that we get approximately equal to 2.5646. So 2.5646. Okay. Let's try this one right here. Log base 17 of 9. So we're going to do the natural log of 9. Remember, this one goes in the numerator. Whatever's inside the parentheses, that's what goes in the numerator. Whatever is at the base by the g, that goes in the denominator. Divided by the natural log of 17. And let's go over to our NumWorks calculator. And we're going to key in natural log of 9 divided by the natural log of 17. And the answer is 0.7755. So I'm actually going to put in 0.776 because the 5, the second 5 will round the 5 up to a 6. I want to stick with 3 decimals. So up here I probably would have just done, oh sorry, that would have made it a this would have made this a 5. There we go. Let me get rid of that. So this would have been 2.565. Okay. All right, let's try this one now. Log base 1.07 of 30, so that'll be the natural log of 30 divided by the natural log of 1.07. We'll go over to our calculator here. We'll key in natural log of 30 divided by the natural log of 1.07. Execute, we get 50.27. This 9, this fourth 9, will round this third 9 up to a 10, which will flip this 6 into a 7, and this will be a 0. So it'll just be 50.27. All right, so this is going to be 50.27. All right, last one. Log base 1/3. Whoops, wrong button. Log base 1/3 of 3 over 58. Okay. Now it's going to look a little weird, but so we're going to have the natural log of what? 3 over 58. It's the whole thing. We're not going to do a log of this and a log of this. This whole thing is inside the parentheses, so we have to do the natural log of this whole thing. So we're going to do the natural log of 3 over 58 over the natural log of 1/3. 1/3. Okay? All right. 3 over 58, 1/3. All right, so we'll do the natural log of 3 over 58, and we'll close parenthesis, divided by the natural log of 1 over 3. Close parenthesis, and press enter, and we get 2.6959. So this will become a 6, so it's 2.696. So 2.696. Okay, and that's how we use the change of base. And also, those are the four properties of logarithms. Now we're going to do some examples in the next video of how we can use the properties of logarithms.